Good day. We are now on our topic, derivatives for basic calculus. So let's start first with slope of a line tangent to a point in the curve. So the slope is a numerical expression of a line's steepness. We already know that since junior high school. It is given by a constant value m from the quotient of the y difference and the x difference of any 2 points on the line. Curves, on the other hand, do not have slopes. We only determine the slope of the line that is tangent to the curve at any given point. This video explains how the limit process is applied to calculate the slope of the line tangent to a point, which leads to the generalization of derivatives. Okay, so let's have this graph of f of x. Now, here we are given 2 points on the graph. We have point A and point B. Point A is at 0 and 1. Point B is at 2 and 3. Now let's recall how to find the slope of f of x. So we said that slope, or m, is equal to the change in y over the change in x, or simply y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, let's go back to the points given. We have A is at 0 and 1, and point B is at 2 and 3. Let's compute for the slope. We have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's equal to y sub 2 is 3 minus y sub 1, which is 1, over x sub 2, which is 2, and x sub 1, which is 0. So we have here 2 over 2, and that's equal to 1. So meaning to say the slope of our function is 1. So we will rise 1 unit up and run 1 unit to the right. Okay, so rise up and run 1 unit to the right. So basically that is the representation of the slope of a line. Now we said a while ago that curves do not have slopes. We only determine the slope of the line that is tangent to the curve at any given point. Now, a tangent line is a line that intersects a curve at exactly 1 point. Now, when the curve of a function is graphed, a tangent line can be drawn intersecting the curve at 1 point. So in this illustration, we see that we have point P on the graph, okay, and we have the tangent, okay, intersecting the graph at point P. Now in calculus, the slope of this tangent line, okay, is of great importance as it can be applied in solving numerous real-life problems. However, the slope can only be measured using 2 points. Okay, but at this time, we are only given 1 point, which is point P. Thus, to approximate the slope, you must first consider a second line passing through P and another point Q on the curve, and let H be the horizontal distance of P and Q. So, alright, we have now 2 points in our graph. Okay, this is point P and this is point Q. The distance between point P and point Q is, okay, let's have it as H. Right? Now, let's have the coordinates of our points. So in general, the coordinates of P is basically x and f of x. And the coordinates of Q since the distance between P and Q is denoted by h, or we let it as h, so we can write the coordinates of Q as x plus h and f of x plus h. Okay, so there we already have the coordinates of our 2 points. Now we said a while ago that we need 2 points on the graph to compute for the slope. Okay, so now we have here secant PQ passing through points P and Q on the graph. So let's find the slope of our secant. So we have m here is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, our y sub 2 here is f of x plus h. So you have f of x plus h minus y sub 1, which is f of x, all over, okay, x sub 2 is x plus h, and your x sub 1 is x, so minus x. Now let's simplify first. So you have f of x plus h minus f of x is equal to, okay, combine like terms, so we can cancel out x and negative x, so we are left with h. Now basically this is now the slope, or how to find the slope of the second line. Now passing through points P and Q on our graph. Okay, now bear this in mind that we are looking for the slope of the tangent line at any point on the curve. Okay, now let's look at the behavior of, okay, our second line as h approaches 0, or as Q grows closer and closer to P. Okay, all right, moving our Q closer and closer to P. Let's see. So we can see here that as you move closer from Q to P, or as h approaches 0, the second line approaches the tangent line. Therefore, to get the slope of the tangent line, simply evaluate the limit of the second line as h approaches 0. Right? So this fact can be used to define the slope of the line tangent to the curve. So the slope of the tangent line can be given as the limit of the slope of your second line, which is f of x plus h minus f of x all over h, now as h approaches 0. So by definition, the slope m of the tangent line to the curve y equals f of x at a point P with the coordinates x and f of x is given by the equation slope is equal to the limit of f of x plus h minus f of x all over h as h approaches 0, provided that the limit exists. Now, this is commonly called as the limit of the difference quotient. Let's proceed to our examples. So let's have example 1. Find the slope of the tangent line to the curve f of x equals 2x squared at x equals 2. So we said a while ago that, okay, slope of the tangent line is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. Okay, so we have now the limit of 2 times x plus h squared minus 2x squared over h as h approaches 0. Okay, so expanding our binomial, we have 2 times x squared plus 2xh plus h squared plus h squared minus 2x squared all over h as h approaches 0. Distribute, so you have the limit of 2x squared plus 4xh plus 2h squared minus 2x squared all over h as h approaches 0. Now we can combine like terms, so we can cancel out 2x squared and negative 2x squared. So we are left with a limit of 4xh plus 2h squared all over h as h approaches 0. Now we cannot plug in 0, or we cannot plug in 0 yet to h because it will make our expression undefined. So we will have to factor out the numerator. Continuing, we have m is equal to the limit, okay, h times 4x plus 2h over h as h approaches 0. Now we can divide out h. So you have here the limit of 4x plus 2h as h approaches 0. Alright, solving for the limit, we have here 4x plus 2 times 0. So we have 4x. Now remember that your point at the curve is at x equals 2. So you substitute or plug in 2 to x. So you have slope is equal to 4 times 2. So your slope now is equal to 8. So the slope of the tangent line to the curve f of x equals 2x squared at x equals 2 is 8. Okay, let's proceed to the next example. Find the slope of the tangent line to the curve f of x equals x squared at x equals negative 1. So we know that to find the slope of the tangent line, we use slope is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. So we have here the limit of, okay, x plus h squared minus x squared, f of x, that is x squared, all over h as h approaches 0. Okay, expand your binomial. You have the limit of x squared plus 2xh plus h squared minus x squared all over h as h approaches 0. Combine like terms, so you can cancel out x squared and negative x squared. So you are left with the limit of 2xh plus h squared all over h as h approaches 0. Okay, factor out your numerator to cancel out h. So we have the limit of h times 2x plus h over h as h approaches 0. Divide out h. So we have here 2, okay, limit of 2x plus h as h approaches 0. Solve for the limit, so you have 2x plus 0. So you have 2x now. Remember that your x is at -1, so your m is equal to 2 times -1. The slope of the tangent line is -2. Right? Next. Find the slope of the tangent line to the curve f of x equals 3x squared minus 5x at point 2 and 4. So we have here slope is equal to the limit of the difference quotient so we have here the limit of 3x plus h squared minus 5 times x plus h minus f of x, that is 3x squared minus 5x all over h as h approaches 0. Okay, so expand your binomial. You have 3 times x squared plus 2xh plus h squared. Distribute -5 to x plus h. So you have -5x minus 5h. Distribute the negative sign. So you have -3x squared plus 5x all over h as h approaches 0. Okay, distribute 3 now. So you have 3x squared plus 6xh plus 3h squared minus 5x minus 5h minus 3x squared plus 5x all over h as h approaches 0. Now combine like terms. So you have, okay, cancel out 3x squared and -3x squared, -5x and 5x. So we are left now with the limit of 6xh plus 3h squared over 8, minus 5h over h as h approaches 0. Right? Now factor out the numerator so we can divide out h. So we have the limit of h times 6x plus 3h minus 5 over h as h approaches 0. Divide out h. So we are left with the limit of 6x plus 3h minus 5 as h approaches 0. Okay, so for the limit by substitution method, we have 6x plus 3 times 0 minus 5. So you have here 6x minus 5. Now remember, okay, the tangent line to the curve at point 2 and 4. So your x there is 2. So you plug in 2 to x. So you have 6 times 2 minus 5. That is 12 minus 5. So your slope is 7. We have already learned that the slope of the tangent line M to the curve y equals f of x is evaluated using M equals the limit of f of x plus h minus f of x all over h as h approaches 0. Now in calculus, the function that gives the general formula for this slope of f is called the derivative of the function and is denoted by f prime. Okay, so f prime of x is just one of the notations used to denote the derivative of the function. Now, in other books or in other resources, we can find dy over dx. We can also have y prime and delta y over delta x. Now, these four are all used to denote derivative. But for the sake of uniformity, for the rest of our discussion, we will use f prime of x to denote derivative. So differentiation is the process of finding the derivative of a function. Okay. So let's have example 1. Find the derivative of the function f of x equals 2x plus 3 using f prime of x equals the limit of the difference quotient. Okay. So let's have our solutions. Now that we are looking for the derivative, we will use f prime of x. Okay, so f prime of x is equal to the limit of f of x plus h minus f of x equals h as h approaches 0. So the limit of 2 times x plus h plus 3 minus 2x plus 3 all over h. As h approaches 0, distribute 2, so you have the limit of 2x plus 2h plus 3 minus 2x minus 3. All over h as h approaches 0. Now combine like terms, so we can cancel out 2x and negative 2x, 3 and negative 3. So we are left with the limit of 2h over h as h approaches 0. We can divide out h, so we are left with the limit of 2 as h approaches 0. Now here, the limit of a constant, so we have 2. So the derivative of our function 2x plus 3 is 2. Okay, next example. Let's find the derivative of f of x equals 4x squared plus 15. So solutions. We have here f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. So we have here the limit of 4x plus h squared plus 15 minus 4x squared plus 15. It's all over h as h approaches 0. expand your binomial, you have the limit of 4 times x squared plus 2xh plus h squared plus 15 minus 4x squared minus 15 all over h as h approaches 0. Distribute 4, so you have now the limit of 4x squared plus 8xh plus 4h squared plus 15 minus 4x squared minus 15 all over h as h approaches 0. Okay, combine like terms, so we can now cancel out 4x squared and negative 4x squared, 15 and negative 15. So we are left with the limit of 8xh plus 4h squared all over h as h approaches 0. Okay, factor out your numerator, so you have the limit of h times 8x plus 4h over h as h approaches 0. Divide out h, so we have f prime of x that's equal to the limit of 8x plus 4h as h approaches 0. Now we can already have the limit through substitution method. So you have 8x plus 4 times 0. It gives us 8x. So the derivative of our function, or f prime of x, is equal to 8x. Okay. Next example. Find the derivative of f of x equals x squared minus 5x plus 8. So solutions. So basically, f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So we have here the limit of x plus h squared minus 5 times x plus h plus 8 minus x squared minus 5x plus 8. Okay, all over h as h approaches 0. So we have here the limit. Okay, expand the binomial, so you have x squared plus 2xh plus h squared minus 5x minus 5h plus 8. Okay, distribute the negative sign, so you have minus x squared plus 5x minus 8 all over h as h approaches 0. Combine like terms, so you can now cancel x squared and negative x squared, negative 5x and 5x, positive 8 and negative 8. So we are left with the limit of 2xh plus h squared minus 5h all over h as h approaches 0. Okay, factor out your numerator, so we can cancel out h or divide out h. So we have the limit of h times 2x plus h minus 5 all over h as h approaches 0. Divide out h, so we are left with a limit of 2x plus h minus 5 as h approaches 0. So for the limit, so we have f prime of x is equal to 2x plus 0 minus 5. So we have here 2x minus 5. Now that is already your derivative. So f prime of x, or the derivative of f of x, equals x squared minus 5x is 2x minus 5. Alright, now let's have example 4. Find the derivative of f of x equals 2 over x plus 5. Now here we are given a rational function. So let's find its derivative. So you have solutions. It's equal to f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. So we have the limit of 2 over x plus h plus 5 minus 2 over x plus 5 all over h as h approaches 0. Okay, so next we have the limit of combining our numerators. So we have x plus 5, no, x plus h plus 5 times x plus 5. 2 times x plus 5 minus 2 times x plus h plus 5. That's all over h as h approaches 0. Next, let's distribute. We have the limit. We have 2x plus 10 minus 2x minus 2h minus 10 all over x plus h plus 5 times x plus 5 over h as h approaches 0. Now here we can see that we can already combine like terms. So we will cancel out 2x and negative 2x, 10 and negative 10. So we are left with f prime of x is equal to the limit of negative 2h over x plus h plus 5 times x plus 5. Right. Now, we have here a complex fraction. Now, we know that when we simplify complex fractions, or when we divide fraction with a fraction, we will take the reciprocal of your divisor, which is h, and proceed to multiplication. So we have here negative 2h over x plus h plus 5 times x plus 5 times the reciprocal of h, which is 1 over h. That is as h approaches 0. Now we can divide out h. Multiplying, we have the limit of -2 over x plus h plus 5 times x plus 5. Okay, let's write our bar properly. Okay, that is as h approaches 0. Okay, now we can already solve for the limit using substitution method. So we have -2 over x plus 0 plus 5 times x plus 5. That's equal to -2 over x plus 5 times x plus 5. Now we can see that our denominator can be expressed as a square of a binomial. So our f prime of x is equal to -2 over x plus 5 squared. Right? Now let's box our final answer. Okay, that is the derivative of the rational function 2 over x plus 5. Okay. So that's it. That's how to find the derivative of a function using the limit of the difference quotient. Thank you for listening and see you in our next video.